YouTube.
What code is
Okay, so this is going to be a lot less of a more informal one than previous ones, because we've got a real noob here. Real live noob. Okay, so I guess the first thing to do is, if you do start up RStudio, what I would recommend you do is create projects. So if you go File, New Project, and then you can do New Directory. Do you know what a directory is?
A location.
It's a folder. Then you can say empty project and type the name of the, so you can say like whatever you want, like plain or testing, or I'm gonna call it plain. I would recommend putting it in the desktop. I mean, wherever you want. I don't really care. It's easier just to put on the desktop because every single like Mac, Windows, Linux all have desktops.
Will it get messed up if you put it on the desktop and try and like move it later on?
No. It should be fine. Because I'll show you in a second. So if you click Create Project, and then it'll open it up as a project. So if you click on, so there's a bunch of like tabs here. So this is a folder, files. You'll see like this file called plain.r proj. So if you move the folder, that file will go along with the folder, and that is what dictates the project. So the reason why I would recommend always for every single like manuscript that you're writing or analysis or whatever, your thesis, each has their own project. And the reason why you want to have that is because it kind of sets the standard to be within that folder, because you want things to be sort of self-contained. So a project is just a way of making it so it's self-contained.
Yeah.
So all your code and all your data and all your manuscripts and writing stuff are all in the same folder, and they're all managed by the project. The next thing to do is do File, New File. And then R script. So do you know what a script is?
No.
Does somebody want to explain to him what a script is?
where you type in the code?
Almost.
It's like a file that has the main code but not the output.
That's a good way of putting it. Yeah. It's just a file that is a series of commands that do stuff. A series of R commands.
So it's like a document. But
Yeah. Yes. So do you know what plain text is?
Yeah.
So plain text is a script is just a plain text file that happens to have a .r at the end, indicating what it is, but it is just purely plain text. And so like if I were to give it to you, a Mac user, or if I were to give it to like a Windows user or anything, they would all be able to see it because it's just plain text.
Right.
Plain text doesn't care, like any operating system can use and look at plain text files, which is one of the reasons why I recommend always using plain text files versus like Word or other proprietary formats, because not everybody can use them. So for example, me, I don't have Word installed on here. So if I do get a Word file from somebody, it's hard for me to, like some of the formatting gets all messed up because I have a different program that kind of mimics the Word, but not exactly. Okay, so then save it. So save a file and just call it processing R. Doesn't matter. So now you should see like a new file here called processing.r, and you'll see at the top here that you're inside this processing.r file. So what? It's that office space or whatever it's called. It's inside the computer. No? Okay. Oh yeah, Zoolander. I was thinking of Office Space. No, that's something different. Okay. So when you can, so the reason why you use an R script is that so that you can write your commands here in this file so you can save them for later. So it keeps a history of what you've done. That's the main reason why like it's good to use statistical packages like R or SAS, because they are code that gives a history of what you've done, versus SPSS generally is just click, 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 or Excel. There's no history of what you've done. So if you were to give the file to somebody else, you have no idea how they generated those results. It's kind of okay. So first thing we're going to do is, if you have it installed, we're going to use reader. If you don't have it installed, go over to the console here and type out install.packages, quotation marks, reader.
On mine it says error unexpected string constant install packages on reader. That would be a technical.
But you need to put in brackets.
Could not find the function. Skip icon. It's spelling wrong. Sorry.
No problems.
You can just click insert. Yeah. And oh wait, no, that it says installed. Yeah.
That should be right now.
Should be.
Yeah, we're
What? No, get reader. Oh, you don't have the quotation.
So, it's like as many errors as you could possibly do.
It's good because it didn't have it.
Honestly, the very beginning is always the hardest part. Always.
Okay.
Like that.
Okay.
Okay.
So now it's running. It's installing.
Yeah.
Okay.
Okay.
So then in the meantime, while you're letting that run, go over to this processing file and type out library reader. So library is a command that loads up the reader package. So when you install a package, reader is that package. And then after you've installed it, then you can then access it using library. So if you want to run a line in the file, you can either click this run button or you can do Control Shift. Is it installed?
It looks like it has, yeah.
Okay. So if you do Control Shift, Control Enter should run the command. And so now you have access to the commands, the functions within that package reader. Now the reason why I'm using reader is it's a very powerful package for importing data and like fixing it up. So there's this one. What type of data do you typically use?
I don't really have a sense. I typically use
You don't know yet? Okay. Okay, well, I'll just go with an example that I used with Gila when she was, so she did like some, she measured some proteins, and then like the machine sort of output this like a standard format of what it calculated. So if you type out read _ lines, quotation marks, https / or colon / github.com / code as manuscript / code - along / tidy data tidy data 4 .csv. So if you run this line, Control Enter, HTTP error. It's www maybe? I think so. Oh, do I have Wi-Fi? I should. Hold on. Oh, I typed it wrong. It should actually be code as manuscript .github.io. There we go. Code along / data / there we go. That should work now. It's kind of hard to see, eh?
Oh,
That's better.
It's kind of crappy projector. Okay, so once you run that, or once you've typed that out, do Control Enter, and it should output this bunch of stuff. Now, what this has done, this command, has just, it simply, so this is a URL to some data that I have put up online. So tidy data 4 CSV. So that data is up online. So all read lines does is it takes that and then reads it line by line. So you can just get a sense of what it looks like. So we know that it's a CSV file. So if you just copy and paste this line, paste it down below. Oops. And instead of typing read lines, do read CSV. We're going to run that again because we know that it's a CSV file, so that's why we're going to do read CSV. So what does CSV stand for? Do you know?
separated value.
Yeah, comma separated value, because you can see here that there's commas, a bunch of commas. And there's, like, if you look further down, there's even more. So it's, we can tell from this particular data set that it's a CSV file. And also based on the end file ending. So CSV is a plain text file. Means that any computer in the world can read it because it's just simply text. And it's one of the more standard data formats that I would recommend you use, and is good to use because it isn't required. It isn't dependent on some proprietary format like Excel. So if you run this command, you should get something that's called a tibble, and then it should say like all this extra stuff. Now, if you'll remember from the very beginning that it had a whole bunch of like these random stuff at the top here, like all these extra stuff, and the actual data doesn't happen until line 23. So we can actually tell this command to do skip. So let's skip to the 24th. So we'll skip 22 lines, and we'll run this again. Okay, it's a little bit better now. So now we have, now we've taken a data set, a raw data set that a machine has output from its, I don't know, from the machine has output, and basically put it into a format that then we can eventually continue to process.
How do you link the skip equal 22 to the read CSV? Mine just keeps coming up as a separate line.
So you do comma inside the bracket. Yeah.
Yes.
Awesome. So we can then take this data set. So we're going to say D4, because it's data 4, 1, and put this data set into this object. So that's what this little like assignment operator is it's taking this data set and it's then putting it inside this object here. So if you run this line, nothing should happen. Well, I mean, like, besides this. Now, we're going to use, like, a lot of these columns we don't necessarily need. So we might want, like, maybe the sample and the assay, but we don't need all this other stuff. And in this particular case, what we actually need is this column here. So what we can do is we can use this package, another package. Oh, if you haven't installed it, do install packages dplyr. Sorry. Did you run it? Is it installing?
Yes. It says
Okay.
that.
So if we go back to here, we do library, dplyr, and then control enter to load it. A dplyr is an extremely powerful package that makes it easy to wrangle your data and get it into different formats. I'm not going to go over it too much because that's like in another session that I did that. But one thing that helps with this is, so in this particular case, we only want specific columns from this data set. So we can use the command called select. And we do D4_1, comma. And in this case, I said we want assay. We want this other one called calc dot, or what was it again? What?
On CONC mean.
CONC, oh, so it's a calc dot conc dot mean.
Yeah.
Okay. Now there's going to be an error. Try to run this. If you run this, error, unexpected symbol in. So that the reason is that R, when you're selecting a column name, there should not be any spaces in that column name. So in order to bypass that, you can use this backtick. So it's backtick, it's right below the escape key. Backtick, backtick. So surround this variable by backticks. And then run this command again. Now, doing that every single time is kind of annoying. So we can rename this column to something else. So if you do calc const mean is equal to, within this select, if you type out calc con mean equals this, what this command will do is it'll take this column name and rename it as calc con mean. So if you run these two lines again, you now have a new column called calc mean. And then it's easier to, you don't have to wrap it around backticks. So we'll call it, we'll put it into new thing here.
Is the ball the same as a data frame?
Yeah, it's essentially the same as a data frame. It's just a tidied up version of it.
It keeps saying to me could not find the function select.
Did you run this this library dplyr command?
Thought so.
Oh, I think you got rid of the spaces inside. So just put the spaces back. Yeah.
Cool.
So the advantage of doing this is that you now have a history of what you've done to your raw data. If you were in Excel, you would have probably like deleted the first 22 lines and then deleted the columns that you don't need. But in this way, you know that there's that now history of what you've done and you can repeat it again. So if somebody were to come to you and say, oh, how did you get what you got? You can show them exactly what you got, exactly. So that's a fairly simple example. Now we're going to do another example using, we're going to do read lines again. So read lines, https://code as manuscript.github.io/code-along/data/tidy data-3.txt. If you run this, got a whole bunch of stuff. Oh, wait.
Okay.
So it's got a whole bunch of this stuff. Just as a quick aside, you can go to the code as manuscripts.github/code-along, and it has the website for each of these workshops that I'm doing. So if you want, eventually I'll put up the notes, and so you can click on like the past, and there will be the notes are online, and then as well as the YouTube, the link to the YouTube video. So if you ever want to go back, or if you missed some of this stuff. Okay, so let's go back to this. So this file has a bunch of like /t's. Now what that exactly is, I'll show you, is so if we do, let's put this into D3-1, run this command. And we do write_lines D3, and then we'll call it tidy data-3.txt.
On mine it says object G3 not found.
Did you run this command?
I thought so, but
So if you run this command, write lines, can you kind of guess what read lines versus write lines does? What does read lines do? I mean,
It tells you all the data that's in the data frame.
Yeah.
Just read it out to you.
Yeah. And then write lines.
Write lines inserts that data because you're calling something D3_1, so it's going to put that into the text file.
You got it. So if we go to files, there's now this new file called tidydata3.txt. So if you want to take a look at it, so open it up. This is what the data looks like. So it's got like a bunch of stuff, and each of those /t's is a tab character. So that's telling us that this is a tab delimited file. So each tab, there's a tab between each of these values. So these are the data that we want. So this is, again, something that comes off of a plate. So there's 1, 2, 3, 4, 6, 7, 8 rows by 12. So this is, again, a machine that Gila was using that there was like 8 plates, 8 wells by 12. And so the machine would go down and do its measurement thing, and then it would output this. Now, normally, like, this might be a little bit of a pain to like try to put into an actual format. And how long did it take you each time just to do it manually?
I think it was like 20 minutes actual transferring pictures per plate.
So 20 minutes per file, and there were dozens of files that she would have had to have gone through.
Great type of thing.
Yes, but if you use programming or coding in this case, that would cut down the time substantially. And you can, I'll show you eventually, the power of this is that you can then do this on each of the files rather than having to run it on each file. You just tell the code to do it on every single file all at once. So I'll show you in a second. So once we've got that, what we're going to do is we're going to do read_tsv because that's tab separated values. We're going to call tidydata-3.txt because that's already inside our folder. So if we run that, command, it should say there's problems. That's because if you remember what the file looks like, it starts at 2. The actual data starts at 4, right? And then there's the column headers here. So 1, 2, 3, 4, 5, all the way up to 12. So we want to again do skip equals 3 because the data starts at 4. Run that again. Or does the data start at, sorry, it should say skip 2 on that. Oh no, it is skip 3. Actually, yeah, so what this does is you'll see that this is actually the first row of the data rather than the column headers. Because the data doesn't actually have legitimate column headers. So actually, how does this work? Let's see here. Why does this not work? Invalid multi-byte string. So if we were to try to include the column header here, it throws an error. And I think probably because of this question mark. I'm not entirely sure why.
You can't start it off with that row because question marks aren't allowed in that row.
Yeah.
In the first row of the code.
Exactly. So in this case, so we're going to say 3, but the advantage to this, so we still want to include a header column. So we say call names going to do paste 0, x 1 to 16, because there is 16 columns. We can see here it says 16. So I'll explain what this does in a second. But if you run it, it now inserts a column header. So what this paste command does is it takes x as a string, and then it adds 1 to x, 2 to x, 3 to x, 4 to x, all the way up to 16. So you now have x1 all the way up to x16 in one line of code. But if you'll see here, we don't necessarily want this first column or the second column. The actual data starts at x3. And if you were to look at column 15 and 16, so in this txt file, you see at the very end of the lines, there's 2 other tab characters at the end of the line. So it thinks that there's actually 2 extra columns than there are. So we don't want those 2 extra columns. So what we can do is, so we want to drop the first 2 and the last 2. So we're going to say, we're going to rename them just to make it easier. We're going to call them D1 for drop, D2 for drop, paste x1 to x12, because we know that there are 12 actual data columns, D3, and D4. We'll rerun that. You have to add an extra. So I use this C command because that command, all that does is it just puts all of this together into one thing. It treats it as one object.
And is there a reason why you use C or something?
It's because C is an actual command. The command stands for concatenate. So, or combine. You can think of it as like combine. So if we run this again, we now have the actual data starts at x1, and then D1, D2, and so on.
To making sure everything is like the right version.
Yeah. Now there's another thing that you'll notice too. The last 2 columns, the last 2 rows are nothing. You're just missing, entirely missing. So we can actually tell this command to do n max equals 8. So what that'll say is that what that does, it says only read up to 8 rows in the file, and don't read after that. Don't include it afterwards. So what that does is then, if we run this, there are no more empty rows at the bottom. So we're not completely done yet. So we're going to put this into D3.2. Did it work?
I mean, it's an unexpected symbol. Okay, looks right. Yeah.
So if we put it into this object, D3.2, run it. Now if we do D3.2, and then add these square brackets. So square brackets say, in this particular case, I want to select only, because we don't want D1, D2, or D3, or D4. So I'm going to say I only want to take rows, columns 3 to 12. So I'm going to say 3:12 says I only want to take those columns from that data set. So if we run this command, it outputs, oops, should be 14. It's 2 from the end. Now we have an 8x12, exactly what the plates are. 8x12. I'm going to put that into a new object. So D3, So now we have something that we can actually now work with and then get into the next stage. The next stage is having the data in this format is not very useful for actually analyzing it, because it's in a matrix format, and that's not necessarily what we want. In this case, we want it in what's called the tidy data set, where each of the values corresponds to an actual observation, because essentially each of these columns were from a subject's sample, blood sample, essentially, more or less. There's a little bit more nuance to it, but that's essentially what it is. So we're going to use another package called, you're going to have to do, again, install packages, tidy R. Again, this is another package that's very powerful at when you combine it with dplyr, you can do a lot of really powerful things with it. So if you install that, once it's done, then you do library tidyr. So run that. We're going to do D3 underscore 3. Now, within dplyr, there's this command called the pipe. So if you do Control-Shift-M, so right at the end of this line, do Control-Shift-M, it should create this kind of like weird percent less than percent. Okay. And that's called the pipe sign. So what that does is it takes this data set, and you could think of it almost like an actual like pipe for water. It takes water and it pushes it to somewhere else. Okay. So in this case, you're taking the data and
that data
to the next,
yeah,
or to the next command.
Okay.
So in this case, we're going to do mutate. That's the command. So mutate, if you can think of what does mutate do? You can try to guess. I mean, based on the word. Mutate.
Alters the data in some way?
Yeah, that's a good way to say it. Yeah. Yeah, no, that's right, yeah. So in this case, it can create a new column.
Okay.
And so because because it's a plate, I'm going to call it plate row. And in this particular case, the plates were labeled as, I think it was A, B, C, D. Was that right?
Yeah.
Yeah. So we're going to call it plate row. We're going to do letters. So letters is an actual command within R that outputs A, B, C, D all the way up to Z. Okay. So if you do 1 to 8, it takes the first 8 letters of the alphabet, because A, B, C, D all the way up to whatever. So that then, if you were to run this line by line, there's now a new column called plate row. Now plate row contains,
The characters.
yes, exactly. Yes, exactly. Now if we want them uppercase, we can change it to letters, all caps. So the next step is, so right now the data is in what's called a wide format, essentially a wide format. We don't want that. We want it into a long format because that's easier to analyze and work with than the wide format. So we're going to use this command called gather. So gather converts wide to long, and it takes the first two arguments to this command. So are the names of the new columns that you'll be creating. So in this case, the new column. So if it takes each, how does this work? If it takes each row and puts it on top of the other, each chunk would be then considered the column. So we want to call it plate column would be the first one. The next one would be called signal because each of those values is the signal from the machine. Now, because there's this other variable called plate row that we want to exclude from this thing, we can say minus plate row. That will exclude it. So if you run this, we now have plate row, plate column, and signal. Did you run this tidyr library?
I was following right up until that point, so I think
Did you use this pipe command at the end here?
yeah, the code was fine until, so I did the mutate line, and then it's this gather line where someone block it. I've got the pipe in there.
The percent sign.
At the end, yeah. Sorry, I should have put more stuff.
So you
Oh,
build
sorry,
it
yeah, I
onto
missed
it.
that. Right, so that was Control Shift
M.
M.
The reason why it's M is because the original package that created this pipe is called Machete, starting with an M. So they used piped it to M.
Okay. What word was that?
Machete?
Was that Margaret, but in Dutch?
No, it's actually French. I'm probably saying it wrong, but it's as close as I can. It's not an actual like French word. I mean, Machete, Machete,
Okay.
but then with an R at the end because it's made for R.
Okay.
So sometimes they just do that. They add like R to the end of things. So for example, tidy R.
Yeah, yeah.
Yeah. So I say Machete.
Okay. Cool.
Yeah.
I'll Google that.
Yeah. Well, if you
Yeah.
Google like, let me see. If you Google Rene Machete.
Oh, great. Yeah.
Machete.
Well, I mean, you could, yeah, that's how you want to guess. Yeah, yeah. Like, this is not a pipe. Better.
Yes.
Yeah. So I see what they did there. It's
Yes.
a very highbrow joke for code.
Oh my gosh, I just got it.
Yeah. So see me about yeah.
Yeah.
Smart.
And that's actually, if you look up Machete, I don't know how do you say it properly. Okay. What?
You're saying it right. It was
Yeah.
just like, yeah, for some reason didn't make a connection between the surrealist artist and a line of code.
See here. Sisitness
Yeah.
Paum pipe. That's why they call it pipe.
Yeah.
That's the R package. Machete.
Very
Yes.
art history jokes.
Yes.
In code.
Yes.
It's cool. Okay. I'm down.
Okay. So now we can then add this. What?
Because it's not actually a pipe. Yes, that's right. Like,
So smart.
that's a good one.
So let's put this into a new object. We'll call it D34. So now we've actually finished we can then take the next step of actually assigning these into individual subjects.
Okay.
That requires a separate step that I'm not going to go over. But so the power of this comes from, like, the power of using these code to like go line by line and to rearrange things is that you can do it on every single file within a folder. So I'm gonna do so if you do write_lines, and we'll take the original one, so D3.1. We're going to call it tidy. We're going to call it tidy data 1. Wait, how should I do this? Yeah, tidy data 01 .tsv. Tab separated. And then run this, and then create 3 more. So copy and paste 3 more, and call them 02 and 03. Then run each. So in your folders, you should now have 01 TSV, 02 TSV, 03 TSV. So if we, now in order for us to run the commands from above on each of these files, we have to actually get the file names into R. So there's this command called list.files. And if you do pattern, because the thing that we want to get is anything that ends in .tsv. So we're going to do pattern equals. So this is one of the powers of R and any programming languages. You can use what are called regular expressions. Now that's like a whole nother topic in itself, but essentially things within regular expressions have special meanings. So in this case, this asterisk means it's like a wild card, which means that it's anything. So I'm saying anything that includes TSV.
Okay.
So that picks up these 3 files. So if you were to run this, it brings back three names, and those are the names of the files. So we're going to put it into an object called data files. So now we have the ability to run these commands on each of these files, but we do need to have it in a way that can easily run on each of the files. So we're going to create a function. We're going to create our own command. So we're going to call it import tsv file. Add a little pipe assignment operator, and then call function. In this case, we want that first argument to be the file name. And we enclose it all in curly brackets. Now, once you've done that, I want you to take each of these. So take this first. So take this read TSV. Take the where we excluded certain columns. Take these other things and copy and paste. Into this function. We're going to tidy it up in just a second, but once you've done that, let me know. So you've done that?
Yeah.
So what we're going to do is instead we're going to say, so this file name needs to be used within this function. So the file name should replace the actual file name. In this case, it's tidy text. So we're going to replace this and call it file name. I'm going to put it into a little bit of a nicer format here. I'm going to change this to just call it data. Data. Just rename every like D3 to just data. Get rid of the library. Organize it just a little bit nicer. There we go. Okay. I'll let you type it out, and I'll kind of break it down.
I think that's all right.
So what this does is just like before, we're gonna, so because it's a function, it's now going to be called import TSV file. So within this function, we're going to give it a file name, and then that file name, whatever I'm going to put in here, so in this case, like tidy 03, is going to be replaced by this. So then it's going to do this thing, import it into there, going to exclude the columns, put it there, do this type of stuff, put it there, and then output it from the function. So you can almost think of this as like a mini separate environment. So like we're inside our workspace right now. And when we run this function, it does its own thing on the side and then comes back and then sends this out.
Okay.
So everything that's done in here is kind of like self-contained.
Okay.
Now what we can do with this next part then is we do a command called lapply. Lapply bracket, we're going to send it data files, each of the data files, and then give it the import TSV file function. So if you run this command, I mean, should say, oh, I have to run this whole function first. So run that.
What is?
And then do lapply. I'll explain what lapply does in a second. Oh, data files doesn't exist. So you have to run data files as well. Now do lapply. There we go. Did it work?
You have to run just that little section of the code.
Yeah.
And then run the whole code.
So starting from here, maybe the easiest way would be to just highlight all of this.
All of the code.
Yeah, from data files all the way down to the lapply.
Okay.
And then just run that.
Still says file name does not exist.
Do you want to?
I think I remember. I always forget what the lapply is supply.
Does, yeah.
Yeah, on the other side.
Do it line by line. So run the first the data columns.
That's working.
And then run the inside of
That looks like it's working.
Okay.
So, that just breaks it.
So bring this down, just say it's right before, right after data. Sorry, right before data.
After
But not,
this.
yeah, after the, yeah. It's in quotation marks. Now try to run it all the time.
Sweet. You're a genius.
Yep.
You're a wizard.
You're a wizard.
Okay, so now we have all of the files in all of the data sets in one thing. So what lapply does is it takes this series of data file names, puts it into this function one by one. So then you get, and then what outputs is called a list. So you can see here, there's 1, 2, and then 3. So those are lists. So there's actually data sets within, so there's 3 data sets within this list. Okay. But we don't necessarily want lists. So we can then pipe this into a function called bind rows. And what bind rows does is it just combines the data set from a list into a data set. So if we run this, we now have a single data set. But we're not done because there's a problem. Do you know what the problem is?
So this doesn't distinguish if it's from file 1, 2, 3.
Precisely. There's no way to distinguish which file it's from. So we have to go back here and say pipe it. We're going to have to create a new column. We're going to call it run, or machine run. Machine run. Now, if you'll notice that the file name, each of the files have a specific name, a unique name. 01, 02, 03. The difference being is 01, 02, 03. So we're going to use that with, we're going to name each machine run based on the file name. So we're going to do what's called, what is it? There's a command called substring. And we're going to take the file name. So in the loop, every single time it goes through the loop of choosing each of the files, it's going to take the name of that file, and we want to extract. So what substring does is it takes specific pieces of a character string, so in this case, the file name, and takes it and then puts it into this machine run. So there's 3 arguments to the substring. There's the file name, or like what you want to extract, when you start extracting, and when you stop extracting. So the first one is start. So we want to only extract 01. So we're going to do ncar. So ncar is just the number of characters within this file name. We're going to do ncar file name. Here. We want to start at 1, 2, 3, 4, 5, 6 characters from the end. So we're going to say -6. And we're going to do the same thing again, file name. But in this case, we want -5 because it's 1, 2, 3, 4, 5 characters from the end. So if we run this command again, and then run this, should get now, oh shit. So sorry, that should be 5 and 4. we go. There we go. 01, 02. Work.
The analyzer, where should the data output? It's that the console out there, right? It's not coming out the same way.
It's
It
not.
looks like it's working, but it's not coming out as. So. There's one right there. So if I run all of that. Just run that.
Oh, okay. Click here. I think there was a problem. So just, yeah. So do either. So do curly bracket. End curly bracket. And enter. All right. So there was just a problem.
For some reason, I wasn't able to put it.
Yeah. So that's why I was saying like plus it's waiting. So now try it again. Run from the beginning. So there we go. Now you can do it.
Great. Okay.
The only thing I would recommend if you pull up, so highlight these two lines, so 33, 34, and then do Command Shift A. So it just
So
tidies
that's why
it
you
up.
like
Yeah, it's better to like have tidy code than
messy.
yeah,
You don't want to. Yeah. You want to be
Exactly.
able to follow along.
because there's certain like if you look at like nice tidy code, there's a certain like elegance to it. It is kind of like artistic how you make your code because like other people, if it's easier, if it's more like elegant and prettier to look at, it's going to be easier to read.
Yeah.
So you can kind of
Good design.
Yeah.
It's
Yeah.
usability.
exactly.
Yeah.
So now we can then put that into an object called data combine. We now have our final working data set that we can do stuff with. And that's how you can process your raw data from beginning to end without having to, come on. We're just about finished. So what would have taken 20 minutes times like 20 would have taken several hours. You had more files actually, yeah, like 40 files. So 20 minutes times 40. You owe me. Just kidding. This is why using code is really powerful because it saves you time in the end. And a lot of people just don't realize that because like, oh, it's too much work. Like it's too much thinking. Like I'm just gonna, well, no, it saves you. Like this is actually a lazy way of doing things.
Right. Yeah.
Because you do less.
Put a little tiny bit of work in at the beginning, and then
Then
it's
you just, yeah.
It's really cool.
Yeah.
It's like I remember learning this term macro way back when for computers, where you pretty much like press one key and it does everything. For
Yeah.
you. Basically, it's like programming a code for this, right?
Yes, exactly. Yeah, macros. SAS actually have things called macros. They're really complicated. Not fun to play around with, but because I'd made them
Right. This is the
before.
kind of thing where basically it'll go into whatever program you're using, just do a bunch more like commands like this.
Exactly. Yeah.
So you're gonna be able to do one individually.
Exactly.
It's really cool.
Yes. So that's it for now.
Thank you.
Yes, no
Thanks so much
problem.
for your time.
Yes.
Yeah.